In this video, we will talk about the similarity theorems that you will need to know to work with similar figures. We are going to use highlighters during this video, so it is best that you pause the video and get 3 different colors of highlighters or colored pencils. So let's talk about the properties of similar figures. Their corresponding angles are going to be congruent, and their corresponding sides are going to be proportional. So corresponding angles are going to be congruent. So if we have angle A, it's going to be congruent to angle X. So angle A congruent to angle X. Angle B is congruent to angle Y. And angle C is congruent to angle Z. So those are corresponding angles, and they are congruent, meaning they're equal in measure. We're also going to have that corresponding sides of similar figures will be proportional. So the corresponding sides will be proportional. So AB corresponds to XY. This side here, AB, corresponds to XY. BC corresponds to YZ. So BC corresponds to YZ. And AC corresponds to XZ. So for similar figures, we're going to have corresponding angles that are congruent and corresponding sides that are proportional. And that's going to make our triangles be similar. So here's our similarity statement. Triangle ABC is similar to triangle XYZ. The A corresponds to the X, B corresponds to the Y, and C corresponds to the Z, just like our angles and sides did in our picture. So some proofs that we use, or some theorems that we use to prove similarity. Some of these should look familiar because when you have learned how to prove congruency, you will use some of the same proofs. However, with similarity, we also introduce a new one, angle-angle. So with angle-angle similarity, if 2 angles of one triangle are congruent to 2 angles of another triangle, then we can say that the 2 triangles are similar. So here's our angle-angle similarity. This angle A, we see our angle, it corresponds to angle D. And then another pair of angles, A corresponds, or angle C corresponds to angle F, because we have 2 pairs of angles, so that gives us angle similarity, because it's 2 angles of one triangle. So 2 angles of one triangle are congruent to 2 angles of another triangle. So they're congruent with 2 angles of another triangle. So then we can say that these 2 triangles are similar. Another proof that we can, or another theorem we can use to prove similarity is side angle side. So if 2 sides of one triangle are proportional to the corresponding sides of another triangle, and they're including angles, so it has to be included. If the included angles are congruent, then the triangles are similar. So let's look at what that looks like for side angle side. So first, let's look at our side. We have AC, that's a side that corresponds to DF, which is a side. We also have a side AB that corresponds to DE, but we have to have, as it states, we have 2 sides of one triangle are proportional to the corresponding sides of another triangle and their included angle. So it has to be the angle included between those sides. So if those angles here and here are congruent, we can prove with side, angle, side. And we read them in order: side, angle, side, to make sure that angle is included. So as we said, we have side, angle, side, similarity. Let's look at the other theorem that we have for side, side, side. If three sides of one triangle are proportional to the corresponding sides of another triangle, then the triangles will be similar. So we actually don't need any angles in this case. We would have a side, so this one has a 1 marking that corresponds to the side, again with 1 marking. We have a side with 2 markings that correspond to a side with 2 markings. And then finally a side that corresponds to a side with 3 markings. So those side, side, sides, side, 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 when 3 sides of one triangle are proportional, those sides would be proportional to the corresponding sides of another, then we can say that the triangles are similar. Some notes: we cannot prove similarity with side, side, angle, or if you even read that in the other direction, angle, side, side. That's a no-no word. We also don't need angle, 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 so those are not similarity theorems. There's no need for angle, side, angle. You should have learned angle, side, angle with congruency, but that's not necessary to have with similarity, because we can prove similarity with just angle, angle. We don't need the side as part of that angle, side, angle. It is enough with our angle, angle similarity to prove with that theorem. We have another theorem that we will use, the triangle proportionality theorem. It states that if a line parallel to a side of a triangle, if that intersects the other 2 sides, then it divides the sides proportionally. So rather than having corresponding sides be proportional, it actually is sections of the triangle. So let's take a look what we have here. We have AE and EB. So those sections, because we have the transversal that's parallel, so this line that cuts and is parallel to a side of the triangle, that side of the triangle that's cut, it is proportional to the AF and FC. So AF and FC. So instead of having corresponding pieces of 2 different triangles within the triangle, those pieces are proportional. So as we're doing some proofs, we have a list of reasonings that you can state when you're proving similarity. Also know some of these symbols. You should have previously learned about congruency. Of course, we need congruency even here now because our angles will have to be congruent, but then we're actually proving similarity of figures. We will work with parallel lines, especially when we see that triangle proportionality theorem. So know that parallel line symbol. The symbol for a triangle, so when you're naming a triangle, you'll use that symbol and then name the triangle with 3 letters. You can name them in any order of those 3 letters from the vertices. Where you have to be careful is once you name your first triangle, the corresponding pieces of the triangle have to correspond in the name. So what I mean by that, back in our first property here, once we named A, B, C, that triangle, because A corresponds to X in your name, it has to correspond. We could not have used any other name. We had to use X, Y, Z because of how we named the first one. But if you would have jumbled up the first order, then that would change how you name the next one, because the corresponding pieces have to also correspond in the naming. When naming angles, we will use the angle symbol, and you'll use 3 letters where the middle letter is the vertex of the angle. Or you can just name angles with 1 letter, and that 1 letter would be the vertex of the angle. However, if more than one angle is sharing the same vertex, you must use the 3-letter naming. Now let's look at some definitions and theorems that you should know from previous classes that they may come up in our proofs of similarities. So the first one we're going to look at is alternate interior angles. So when we're dealing with alternate interior angles, we have 2 parallel lines are cut by a transversal. Then the pairs of alternate interior angles are going to have the same measure, that congruency, which is what we need to prove similarity. We need congruent angles. Alternate interior angles are non-adjacent angles that lie on opposite sides of the transversal between the intersecting lines. So let's draw ourselves a picture so we can know what we're talking about here for alternate interior angles. Well, first it said that when you parallel lines, in order to note that these are parallel lines, you can place a little arrow, and that shows that you're wanting those to be parallel. So if 2 parallel lines are cut with a transversal, so now we want a transversal, then our alternate interior angles are going to be non-adjacent angles that lie on opposite sides. So this angle and this angle will be alternate interior angles, and they are congruent, meaning equal in measure. Let's look at our next one. Complementary angles. Complementary angles are a pair of angles whose measures add to be 90 degrees. So if we have these 2 angles, then this angle measure plus this angle measure would equal 90 degrees. So let's write out the green plus the blue is going to be 90 degrees. It is the right thing to give someone a compliment. So it's a right thing to give someone a compliment, and a complementary angle add to give you 90 degrees, which is a right angle. Corresponding angles. If 2 parallel lines are cut by a transversal, then the pair of corresponding angles have the same measure. Corresponding angles lie on the same side of a transversal and on the same side of the intersecting line. So again, let's draw our picture. We have our parallel lines and our transversal. And so denote that these are parallel with our little arrows. So when we're talking about corresponding angles, let's see here, corresponding angles lie on the same side of the transversal and on the same side of the intersecting lines. So that means we're going to have this angle that corresponds to this angle. Those are the corresponding angles, and they are congruent. Isosceles triangles theorem. For the isosceles triangle theorem, if two sides of a triangle are congruent, then the two angles opposite of those sides are congruent. So isosceles triangles have two equal sides. Let's draw ourselves a triangle here. We do want it to be an isosceles triangle, so that means we're going to make these sides equal. And because those sides are equal, the angles that are opposite will be congruent. So this angle that's opposite the side will be congruent to the angle that's opposite the other side. So that helps us with congruency, knowing that these angles here and here that are opposite those two sides of the isosceles triangle will be congruent. The reflexive property. An angle, line segment, or shape is always going to be congruent to itself. So that seems very common sense, but really when we see it the most is maybe like when two triangles are sitting right next to one another. So that just means if we have this triangle here on the left, this side that shares with the triangle on the right, it just means that those are going to be congruent to each other. So let's maybe name that A, B. So it's just saying the reflexive property, that side AB is going to equal itself AB. So AB in the left triangle is going to equal AB that's in the right triangle. That's that reflexive property. It could also work with an angle or shape, but with similar figures, this is where we see it most often, is when a side is being shared. That line segment is being shared from the sides of our figure. Our next one, right angles are always congruent. So again, another one that seems to be common sense, but it's one that is true. Right angles are congruent. And because with similarity we need congruent angles, this will be handy. So if you have a right angle, then that means it's going to be congruent to all other right angles. Those are going to be equal in measure. So that angle equals the angle of the other right angle. Again, very much common sense, but this is something that will help us since we need those congruent angles for similarity. For supplementary angles, a pair of angles where the sum of their measure is 180 degrees. So if we have a pair of angles, so maybe like those, this angle here on the left plus this angle here on the right. So let's mark those with our colors again. So the orange angle plus the blue angle for my colors. supplementary, when we add those together, they're going to be 180 degrees. The triangle sum theorem. The sum of interior angles of a triangle will always be 180 degrees. So if we have our triangle, those three angles, so here plus here, and finally here, the sum of the angles of a triangle. So when you add those angles together, it is 180 degrees. And of course, this is handy when we know two of the angles. Maybe we know those measurements. We can find the missing measurement because the sum of the angles is 180 degrees. And our last one here, vertical angle theorem. Angles that are opposite each other and formed by two intersecting lines, they will be congruent. So if we have intersecting lines, those intersecting lines, when we have vertical angles, so this angle is a vertical angle to that one, those will have congruent, those are congruent angles, meaning they have equal measures. We would also have a pair of vertical angles in this direction that would also be congruent.